Hi everyone, today I'm going to be discussing hydrogen deficiency index or degree of unsaturation. And the hydrogen deficiency index can be useful when figuring out the structure of a molecule, like if it contains pi bonds or rings, when given the formula, and it can also be very useful when looking at an NMR spectrum. So, what does it mean for something to be fully saturated? For something to be completely saturated, it means that it has the maximum amount of hydrogens present possible for the amount of given carbons. How do we know how many hydrogens a molecule needs to be completely saturated? So we have a formula we can use, and this formula is 2C plus 2, and this will give us the hydrogens needed in the molecule for full saturation. The variable C in this equation is how many carbons are present. So if we look at pentane, for example, there are 5 carbons in pentane, so our variable C will be the number 5, and we will do 2 times 5, which is 10, plus 2, giving us 12, and this is how many hydrogens are needed for pentane to be completely saturated. If we also look at the formula, we have C5H12, so this will give us our hydrogens needed for saturation and formula. How do we assign an HDI or a degree of unsaturation? So in order to assign it, we have to determine how many pairs or sets of 2 hydrogens are missing. For every 1 pair, that is 1 degree of unsaturation, or it is an HDI of 1. So if we look at the pentene formula, which has a double bond, it is C5H10. We know that for pentane to be fully saturated, we would need 12 hydrogen. And in pentene, we only have 10, so therefore we have 2 missing hydrogens, or 1 pair, giving us an HDI, or a degree of unsaturation, of 1. And as you can see, this degree of unsaturation was caused by the double bond present. Our next example is if we look at cyclopentane, which also has a formula of C5H10. And since we have the ring, that causes us to lose 2 hydrogen. And that 2 missing hydrogen will give us the HDI, or the degree of unsaturation, of 1. Furthermore, if we look at cyclopentene, the formula is C5H8. We have a ring and we have a double bond in this structure. So if we know that pentane needs 12 hydrogen to be completely saturated, and we know that we only have 8 present, we can take the amount needed for full saturation, subtract what is present, and that'll give us 4. If you divide that by 2, that will give you your HDI, or your degree of unsaturation, for this molecule, which is 2. So we can see a trend going on where if there's a ring present or there is a double bond present, that will cause you to have an HDI, as it is having you lose hydrogens. So there is an overall formula for finding HDI, and that's what we're going to look at next. So the most basic formula for finding your hydrogen deficiency index is 1/2 times our 2C plus 2, and if we remember, that's what we use to find how many hydrogen are needed for full saturation. And then we're going to subtract the hydrogen that are present. Now, when you get into a molecule that contains nitrogen, that will give us a new formula of 1/2 times 2C plus 2, plus the number of nitrogen present, minus the number of hydrogen present. And lastly, the third thing that will affect your HCI is the presence of halogens. So if we have halogens present, if we also have nitrogens present, our formula is going to be 1/2 times 2C plus 2, plus the number of nitrogen minus the number of hydrogens and minus the number of halogens. Nitrogens and halogens are the only two things that will affect your HDI, so you do not need to worry about the presence of anything else. So for our first example, we have the formula C6H6, and I will give you a minute to figure out what the HDI or degree of unsaturation is using the equations we just talked about. So we can use the most basic equation for this one, which was the 1/2 times 2C plus 2 minus H. So if we plug in our carbons present, which is 6, and our hydrogens present, which is also 6, we have 1/2 times H, what gives us an HDI or degree of unsaturation of 4. For our next example, we have a formula that includes the presence of nitrogen. So I'm going to give you a second to figure out the HDI of C5H7N. For this example, we can use the second equation, which is 1/2 times 2C plus 2 plus N minus H. We have 5 carbon present, we have 1 nitrogen present, and we have 7 hydrogen present. So once we plug that in and do the math, we have 1/2 times 6, which gives us an HDI or a degree of unsaturation of 3. And finally, we have what is the HDI of C7H9N2Cl3. I'll give you a second to figure out the degree of unsaturation for this. So we can use the longest or the most final equation, which is 1/2 times 2C plus 2 plus N minus H minus X. So we have 7 carbon present, which we can plug in. We have 2 nitrogen present, which we can plug in. We have 9 hydrogen present, which we've plugged in. And we have 3 chlorine, which is our halogen present that we've plugged in, giving us 1/2 times 6 and an HDI or a degree of unsaturation of 3. So in conclusion, we can use this to figure out how many pi bonds or rings a formula has. And we can also use this when looking at NMR structures to really understand and figure out what molecule we're looking at. I hope this helped. Thanks, guys.